So, welcome and thank you all for being here. I'm Stephen Pruitt, President of the Southern Regional Education Board. Probably, if you're listening to this right now and you can hear this accent, you probably are pretty clear this must be a Southern thing. We are an interstate compact that supports the improvement and the efficiencies of education across the Southern region, as you can see in the logo above my shoulder. We have the great opportunity to work with everybody from, the people who are doing the most important job of delivering instruction to our students, to work with our teachers, all the way through working with governors and state school superintendents and legislators. So it's a real pleasure when we get to do things like this, especially for me. I'm a science guy. I'm a former science teacher. I've been working at the national level on science education for a long time and had the great pleasure of getting to work with Dennis before today. If you're not familiar with Dennis, let me just tell you a little bit about the guy. I'm not going to read this whole bio because it'll take the whole time we're supposed to be on here because he's done so many incredible things. But Dennis Schatz is literally an internationally known astronomer. He has worked in all kinds of positions, most recently at the Pacific Science Center out in Seattle, Washington. He is the retiring president of the National Science Teaching Association, which is in the presidential chain. So last year was his presidential year. And he's just done all kinds of things, gotten all sorts of accolades. He's had the opportunity to be named as NSTA's distinguished educator and great contributions to science. But when I say he's a rock star, it's not unfair to say that he's a space rock star. He actually has an asteroid named after him, which is pretty dang cool. And it's not one that you actually pay for. This is actually where the International Astronomy Association named an actual asteroid after this guy. So we are so happy to have him, so happy that we got to have him with us. Most of all that stuff, I'm proud to call Dennis my friend. And when I get to see him, I get to go to dinner with him. I get to just enjoy his intellect and his sense of humor. So with all that, I'm going to turn it over to Dennis, and I'm going to let him take it from here and share with you some great resources and maybe some ways that you can help your administration see the importance of what's about to happen. Dennis, take it away.
All right. Thank you, Stephen. I appreciate it. I also enjoyed working with you over the number of years. It's great to be able to call you a friend also. And I do want to thank the Southern Regional Education Board for providing this opportunity for me to talk about eclipses, and to thank the staff for putting it all together. I really appreciate it. I'm going to share my screen here so that we can get started. So I'm going to be talking about teaching resources for this upcoming eclipse. I hope everybody is well aware of Monday, April 8th, as the last total solar eclipse in the continental United States until 2044. And even in the one in 2044 barely goes into Montana. It's really 2045 when there'll be another total solar eclipse across the United States. So we have a whole generation to wait for the next eclipse. And what I want to do is to cover just four things. What are solar eclipses? What makes them special? Why is it everybody's getting hyped about what's going to happen on April 8th? What are some resources for you to use? And then some sample of what teachers are doing that we know of around the country, so that you might think about things that you can be doing besides doing things in your classroom. And then finally, we'll talk about safe viewing strategies. So that's really the plan for the hour that we have together, a little over an hour maybe. What's really amazing is we've had 6 months of just a lot of solar eclipse activities. Really had an eclipse double header. Don't know if people got to see one back in October. It was really in the Western United States. Coming up on April 8th, it's more aligned to the southeast part of the United States. And even if you're not in the path of totality and see a partial eclipse like this, there's some wonderful things you can see, like the sunspots that are on the sun. And this is a good example of a view you might get. Of course, sunspots are a little bit like solar acne. They grow, they fade away, they move in different places. So this isn't exactly what you'll see when you go out on April 8th. And we live in a very special place and a very special time in the solar system. What I'm showing you here is the attempt of a moon of Mars, this is Phobos, coming in front of the sun. And as you can see, it's doing a pretty pathetic job of covering the sun. We have a situation where the apparent size of the moon is just exactly the same as the apparent size of the sun. The sun's 400 times bigger than the moon, but it's 400 times further away. And so when there's a solar eclipse, there's the opportunity for the moon to just cover the sun, and you get to see the beautiful solar corona. But there's actually 3 different kinds of eclipses that we get. We'll talk a little bit about this. When the moon is close enough to the Earth, it totally covers the sun, you get a total eclipse. When the moon is further out in its orbit is not circular, it's an ellipse. When it's further out, the moon appears a little bit too small to cover the sun completely, and you get an annular eclipse, like in the second photograph. And then some of the time, the moon just doesn't cover it, gets a partial eclipse. It's just not aligned completely. So we have these 3 different kinds of eclipses. And of course, last October, we had this beautiful annular eclipse where the moon was further out in its orbit. I hope people got to see it. But what we're talking about now is what people are calling the Great North American Total Solar Eclipse, April 8th, 2024. It will go through Mexico, the United States, and Canada. And if you get to be in the path of totality, you get to see something like this. This is actually just the moment before absolute totality, called the diamond ring effect. You can see just a little bit of the sun, but you can start to see the corona sticking out there in a very nice way. And what's great for the southeastern part of the United States is it's very close to the path of totality. Actually, parts of the Southern Regional Educational Board states, Texas, Arkansas, a little bit of Kentucky, will be in the path of totality, but it'll be close enough that even down in Florida, it's like 56% coverage of the sun. So the southeastern part of the United States should really get a pretty nice view. And to get a sense of timing, well, I should say that if you want to see totality, you have to be in that narrow space here between the 2 blue lines. The red line is the center line. That's where you get maximum totality. But everybody outside, everywhere in North America will see a partial eclipse. And to get a sense of what timing is like, we picked up just a couple that are in the southeast. So we have Arlington, Texas here. Totality is at 1:40 in the afternoon, probably before school gets out. Arkansas, 1:50. You can see this path is moving, or the shadow of the moon across the Earth is moving very quickly. And then moving up into Indianapolis, you'll see all of a sudden it's 3:06. That's because we've gone into the Eastern time zone. It really isn't that many minutes after being in Arkansas and then Illinois and in Indianapolis. But it does mean in the south, or sorry, well, in the southeast, but in the Eastern time zone, it's going to be happening around release time for many school districts. And that's something we'll talk about a little bit later. That presents some problems, and has been a discussion that I've been involved with lots of states about what to do. Schools are canceling classes, some are having early release, lots of things to think about. The big challenge is the weather. I mean, you not only need to be outside to see the total eclipse, or it has to be happening at a certain time, but you need to have a clear sky in order to see it. And you find that the further north you are, the more likely it is to be cloudy. Here's a graph of cloud cover, and you see if you really want to see this, you should be in Mexico. The total eclipse comes in Mexico and goes up through Texas, then up into Arkansas and into the Midwest and northeastern states. But down here, you know, if you're in Mazatlan, you have only a 25% chance of cloud cover. So you have a great chance. But if you now come up to Little Rock, it's a 50-50 chance. But at least that's better than being up here in Indiana, where there's a almost 70% chance of cloud cover. And you certainly don't want to go to Quebec to observe the eclipse. If you want to find out, and again, the video will be recorded, and so you can always come back to this. You don't have to write it down now, but you can find out what's going to happen in your place by going to this www.timedate.com/eclipse. Put in your location, and it'll tell you exactly when does the eclipse start, whether it'll be total in your area, not total, when will be maximum coverage, etc. The situation we have is that if you look at the path of totality, there's going to be almost 32 million people who are going to be there and want to observe this eclipse. That's a lot of people. So much discussion about how to handle traffic, accommodations, restaurants, that sort of thing. But equally important is to think about, even if you're not in the path of totality, you'll see a partial eclipse, some kind of eclipse. And so there'll be around 500 million people in the United States, Canada, and Mexico wanting to view the eclipse. And of course, we'll talk about how good ways to do that and so on as we go on. But it does mean we've got our job cut out for us to prepare our students and really to prepare families and people in the community. Educators are a great resource for the community. So let's start talking about some great resources. Of course, I've been involved with the National Science Teaching Association, as Stephen mentioned. And a colleague of mine, Andrew Facknoy, and I developed the Solar Eclipse Resource website. It's really a web page on NSTA's website, and you can see the URL here. If you just go to nsta.org and search under Eclipse, or even Google NSTA Eclipse, you'll get up this web page. And we like to think of it as one-stop shopping for what educators need to know in order to be effective in the classroom and really in the community. So this is what the landing section looks like. But if you scroll down, you'll find some really important documents that are all free. Download these. On the left over here, you'll see is a 28-page educator's guide. This gives you background. A lot of the things I'm saying now, those are the charts of what's happening in different parts of the country, say viewing strategies. The last 4 pages includes what you see here in the center. These are handouts to send home to parents, and especially if your school is canceled. These are ready to print. There are 2 pages really, so you can do a single page on both sides to tell parents, families, what's happening, what will be happening in your location. So that's all in the Educator's Guide. Some of you may be, I hope you've already ordered your Eclipse or your solar viewing glasses, if that's what you're going to use. If you haven't, there's information about how to do that in the 28-page guide. On the right is the Administrator's Guide, something that Stephen mentioned. It's a 4-page guide, just right for administrators. You know, you don't want to overload them with too much information. They've got a lot of things that they need to deal with besides the eclipse. And what's really nice about this 4-pager, it really focuses on 3 things. It talks about how important and how wonderful eclipses are, the learning experience. You actually get to go outside. How safe they are to view. There was a wonderful study done by ophthalmologists, not by astronomers, but by people worried about people's eyes. A study done in the UK when there was a solar eclipse in the UK, and they found, after doing a study of the entire, the population in the UK, that there was no permanent eye damage to anybody. So they really are safe. There's this whole idea that you just look at the sun a moment, and you go blind or you have permanent damage. That's not true. People don't like to look at the sun. It hurts. So people, it is really safe to go out. Some people think there's extra radiation or something during an eclipse. The sun, it's no different than it is when there's not an eclipse. It's just more interesting to look at the sun at that time. And then there's a number of safe viewing techniques. So I hope that you can use this with your administrators to make them feel calm about the opportunity students should have to go outside. In fact, it's probably safer to go outside and view the eclipse than it is to go on a field trip where you have to go on a bus and out in traffic. So think about it that way. So if you keep scrolling down on the web page, you'll find that there's a bunch of free web seminars. In the past, I would have said, well, you should participate in them, but I really like what we're doing now. So you are getting one of these web seminars. But if you have colleagues, I certainly encourage them to come and listen to the recording of this web seminar, but there's ones that they can also view through NSTA. NSTA Press has two nice publications. The one on the right is for teachers. It's curriculum materials used in the classroom. I'll talk about some of the activities from there that you can do with your classes, with your students to understand what causes eclipses, what's happening. And then we have a children's book called When the Sun Goes Dark. It's all about some grandparents who come home. They're eclipse chasers. They go all over the world to find eclipses or to view eclipses. And they come home just in time for their granddaughter's birthday. And so the grandchildren start asking questions of why, what's a solar eclipse? Why do you travel 10,000 miles and spend $10,000 to go see an eclipse? And the grandparents become the educators and use styrofoam or use tennis balls and lamps and hula hoops to explain what's happening with the solar eclipse. It's a great complementary book to use in the classroom as a read aloud with your students. And then if you're an NSTA member, you would have gotten the most recent, I shouldn't say, well, now the most recent, but the fall or last summer issue of the 3 K-12 journals all had articles about the solar eclipse, information on how to view it safely and so on. These now, all of the articles are now in front of any paywall. So if you're not an NSTA member, you can actually go to these and get the articles without being an NSTA member. And this is all on this one page as you're scrolling down. You keep on scrolling down, you come to a NSTA collection. We've added a whole lot of other resources to this collection. There's one on how to use interdisciplinary activities to talk about eclipses. There are free web-based activities that you can use in the classroom. So there's a whole lot of additional things. So you should check it out and see if it works. There are things that work for you in the classroom. And then finally, at the bottom, if you scroll down, we have links to all these other people that are doing solar eclipse engagements, activities, and so on. NASA certainly is, American Astronomical Society, the Astronomical Society of the Pacific, and so on. So we really do like to think of this as one-stop shopping for people. So now I'd like to move in. I'm going to have an opportunity for questions. So if you've got them, feel free to put them in the chat, and we'll take some time to break from my monologue to make sure that you have a chance to ask questions. But let me go on to talk about some learning experiences you can use in the classroom. Certainly, if you have the solar science publication from NSTA, you'll find that Chapter 4 has a whole set of activities on observing the moon, modeling the moon. You might say, why are we modeling the moon? Well, you have to know what causes the phases of the moon to understand what causes eclipses. So that's an important element. Finally ending up about modeling what causes eclipses. And at the bottom of this, I'd actually put, if you don't have solar science, there is a PDF of the materials that I've made available, which you can see at that URL at the bottom. The key thing, and this is probably, for almost every classroom, Certainly third grade through adult. Often the activities that we talk about that are good for elementary actually work really well for adults too. Their understanding of the eclipses is about the same as a fifth grader. Maybe when you get down into really young grades, this might be a little bit more challenging, but it's still a valuable learning experience. It's a very simple process of essentially having students use their heads as the earth, light bulb. Here's a simple lamp with the shade taken off. And you'll show assign a styrofoam ball on a pencil in this case, but you can use tennis balls, ping pong balls, and so on. And you ultimately end up showing how the phases of the moon, for one thing, are made by where the moon is in its orbit around the sun. And then when you look at the top right image here, you can see that a solar eclipse occurs when the sun is in the direction, when the moon is in the direction of the sun and you're at the new phase. So you find out through this kind of modeling activity, which is one of the important scientific practices we like people to use. This kind of modeling activity exactly fits in with the next generation science standards. It fits in with almost every state standard that I know of. So this modeling activity is good in terms of a learning experience, as well as the perfect opportunity to understand what's happening when they go out and observe the eclipse. So moon has to be in a new phase. Actually, it allows you to figure out that in order to have a lunar eclipse, because this comes up too, the moon has to be in its full phase. And you also learn about phases of the moon. So it's a great learning activity. There's lots of other ones. If you go to the collection, you go to the resources that are on the NSTA page, there's lots of other activities. But this is the one I think that is perfectly suited or extremely well suited for use in the classroom around the solar eclipse. And what you find is shown in this diagram, and I already said this, is that the moon has to be in the direction of the sun. So you have the dark side of the moon facing towards us, the new moon. For a solar eclipse, you can see that only part of the Earth gets to see it. And then for a lunar eclipse, students will discover you need a full moon. The lit side is facing towards the Earth. And what you find, of course, is that everybody on the nighttime side gets to see a lunar eclipse. And actually what then comes, when you do this modeling activity, what you find is that all these questions come up there. It's wonderful learning going on, but you just can see the minds of the students thinking about all these questions. So if we have a full moon and a new moon every month, which comes out of the model, why shouldn't we have eclipses every month? Why are they so rare? Why are they so unusual? In 2017, it was the first total solar eclipse in the US in 40 years, almost 40 years, 39. And of course, we won't have another one for another 20 years. And why do these people spend so much money to go so far? Wonderful questions. And there's some great activities in solar science about how to use hula hoops to really understand the characteristics of the orbit of the moon and the orbit of the Earth around the sun to explain why we don't get eclipses every month. We get them every 6 months. I'm not going to go into those details, but you can find that in the resource materials. And to give you a good example, I've taken a picture of myself, which is always scary, to understand why so few people see the total solar eclipse. So here we have, thinking in my head, as the Earth, and that styrofoam ball is the moon. And of course, off to the left, kind of front left of me, is the sun. And you can see that you have to be in this small area of the Earth. This is actually bigger than it really would be. That path of totality that I showed on the map earlier is only about 100 miles across. But you can see for a total solar eclipse, only a limited number of people get to see it. You have to be in that path of totality. And here you can see actually a picture taken from space. The small amount of area that the moon's shadow covers on the Earth, going across the state of Ohio takes about 10 minutes. Happens very quickly. it'll cover the entire United States in 90 minutes. So it's moving at almost 4,000 miles, almost 2,500 miles per hour, 4,000 kilometers per hour. Now, to really understand why no one really seems to get as excited about lunar eclipses, here we can now see, here again, the sun's off to the front left. My head's the Earth, and now I've got the moon sitting here in the shadow of the Earth, my head. And you can see it again, everybody on the back side of my head could see the lunar eclipse. So lunar eclipses are kind of dime a dozen, pretty easy to see. Don't have to worry about them too much. And here you can see, get a sense of, again, why going to see a total eclipse is a bit challenging. These are total and annual eclipses between 2021 and 2030, so 10 years worth of them. And you see they do happen often. There is an eclipse every 6 months, total, annular, or partial. So this doesn't include the partial ones. But you can see here's the 2024 path across the United States. Here was the October 23. So those are the two that are here. If you're sitting there and saying, you know, I'm not going to get to see this one, but I want to see one, I recommend 2026 in August, goes through Iceland and then through Spain. August, well, depends. August 12th, don't know when school starts exactly. This will be right around school start for some people. A great time to go on a trip. August 2027 through Africa, that's not bad. And then 2028 down here in Australia. But what you find is most of these paths, as you might expect in a world that's covered mainly with water, the path is generally over water. So that makes it even more complicated. And sometimes it's down here in Antarctica, up here in the Arctic and so on. So people want to travel are willing to travel long distances and spend lots of money. So what you end up with are these total solar eclipses. So this is something, if you're in the path of totality, this one, the corona is not as easily seen because it's showing that when you look closely during totality, you can see these amazing clouds called prominences on the surface of the sun. And I recommend you actually, if you're in the path of totality, take your binoculars, only use them during totality, not during the partial phases, but during totality, binoculars will allow you to see this kind of detail of a total eclipse. And of course, then there's an annular eclipse and then partial eclipses. And what you find is when you really look at this, it's about a third and a third, a third. Only 20%, 27% are total, 33 annular, and 35 only partial. So while there's a solar eclipse every 6 months on average, and that's just dealing with an average, it's every 18 months for a total eclipse. Of course, it's not always every 18 months, but so they are a rare event, and they only have that width that's about 100 miles across. All right, I've been talking for a while here. I'd be happy to look at what people might be saying in the chat. Whoops.
Feel free to put your questions into the chat. We had one that talked about, Juliana told us how much she has really enjoyed this. She's about to meet with middle school science and math teachers, and she can't wait to share.
Oh, fantastic.
Yeah. Right now, we don't have any other questions in the queue that I see.
Right. Well, I will move on then. So I want to now talk about, I've gotten to 2 of the 4 items that I said we would talk about. Some examples of what people did for the 2017 eclipse, and then what some people are doing for the upcoming or did for the annular eclipse, and then what they're doing for the total eclipse. This is one teacher, spent an entire day of STEM events for the students centered around the sun, moon, and shadow, etc. They had NASA approved. I don't know if NASA, she said NASA approved, but we are concerned about glasses that have the right specifications. The 28-page document that you can download has approved sites or approved places where you can get solar viewing glasses. If you go to the American Astronomical Society site, they have even more locations. So you can still purchase glasses. I was just on yesterday for some friends, and a couple places they're around $3 a pair of glasses. If you want like 25, now if you want 1,000, they're probably cheaper. But they are available. Last time in 2017, they were a bigger challenge. And I will talk about, and I'll say this now, solar viewing glasses are a little bit overrated. You get this very small image. Not everybody actually needs solar viewing glasses. Watching the partial phases of the eclipse, again, if you're in totality, during totality, you have to take glasses off. But during the partial phases, watching the partial eclipse occur, it takes about 3 hours from the time the moon starts to cover the sun until it totally uncovers the sun. It's a bit like watching ice melt. So it happens very slowly. So people can actually share glasses. They don't actually, everybody doesn't have to have one, although I understand why everybody wants one. This person invited a meteorologist to come, had an eye doctor come, talk about safety and so on. We had one very enterprising teacher who bought glasses and then had information cards that went home and sold them for $1 a piece. She bought them for 50 cents a piece, sold them for $1. I don't know if you might have to buy them for $1 now and sell them for $2, but they made money for future activities at the school. Interesting idea. In addition to getting information about safe viewing to families, back in 2017, it happened in August. So a lot of schools actually weren't in session yet. Examples from 2023, we had one high school teacher who worked with her science students, her science club, and they actually developed a website. It's called the Friends Central Moon Shadow Team. And the teacher, Deborah, out there, she was the leader, but then the students, Astrid and Andrew, and there were more students than this, developed this website, told about who they were, learning activities for the school district and the community, and actually went out and they did presentations at a middle school, a church, a local library. I get excited when students are actually become the teachers. They go out, we know that they're going to learn even more when they become the teacher. You learn the most when you actually teach others about it. So very exciting. So from Duluth, Georgia, example from down in the Southeast, this teacher had a big activity or a table that she set up with art activities to produce a corona, solar corona with chalk and black construction paper. She had information. She actually had there's a sun spotter telescope here. She has a telescope that lets you look and see what's happening on the sun. And she did that at the school, but did it out at the local library. And she actually went to a local festival and did it also. So these are the kinds of things. Might be getting a little late to organize all these things, but these are the kinds of things that were being done. And here in Columbus Grove, Ohio, this elementary school student elementary school teacher took his students out to do library programs and do an activity station at a local library also. So all kinds of things that teachers are doing. I actually have another opportunity to stop for questions here if there are any. So I think I'll do that, and then we'll talk about safe viewing strategies.
Anybody have any questions? Feel free to put it into the chat.
Good to know I'm being so thorough.
I was about to say, Dennis, you're doing just such a dang good job. You know, people are having all their questions answered.
Yeah, there'll be an opportunity at the end too. I certainly won't take the entire time. And maybe especially when we get to safe viewing strategies and talking a little bit about challenges around release time and that sort of thing, which we'll get to at the end. Okay, is that it? I think we'll move on then.
I believe so.
Okay, safe viewing techniques. Here's 2017. This is the way a lot of people want it. You know, it's safe viewing glasses. I should point out that I've been part of a major effort to distribute a large number of safe viewing glasses through public libraries throughout the country. 13,000, over 13,000 public libraries funded by the Moore Foundation. And this shows Google. That was actually in 2017. I meant to change that. NSF has actually helped fund part of this too. So one thing you should do is to check your local library. If you need glasses, now they probably don't have glasses for a whole school. They're giving them out typically for people attending Eclipse related programs. But certainly you might check with your library to see if there are any glasses that might be available. And they would be a good group to talk to about programming that your students could go to, their families could go to, how you might get involved. So check your local library. And we picked libraries. Some people say, so why libraries? Libraries occur in every community. They're free. And one of their purposes is to give out information to people. And so libraries are a logical spot, and they are very excited about being able to be a central depository of information about the solar eclipse. So please check with your library to see what they're planning and see if they're a participant of the solar eclipse activities for libraries project. So again, I think glasses are a little bit oversold. You get to see this really little image of the sun through it. You can't see any sunspots. I mean, I have to have a really big sunspot, you could see it, but in general, you can't see them. And as I mentioned earlier, watching the partial phases is like watching ice melt. And so one enterprising group, which I thought was a good way to do this, when I said you don't need glasses for everybody, they set up a solar viewing clothesline or glass line, I guess you would call it. And so they have these glasses hanging down, and people come up, pick up the glasses, take a look through them, and then go off. And typically if you're going to have a time where students are out observing, you want to have other activities going on. Often they're schools that I've been involved with turn it into a party. So there's food and drinks, music, other kinds of activities like that. Chalk art activity with making the corona with chalk on black paper. Solar viewing, if you have telescopes, and project an image. I'll talk about that. You don't look through the telescope, you project an image of the sun so that it's safe. But this is a good way to do it if you have don't have solar viewing glasses for everybody. But one of my favorites, you look through the solar viewing glasses, you have this little small image of just the sun. Everybody, I shouldn't say everybody, but many people have a pasta colander or salad colander, whatever, a strainer in your kitchen. So you just need to take that outside. Every one of those holes acts like a little pinhole projector. And if you hold, this is a person holding the colander kind of at shoulder level off to the side. The sun comes through the colander and is shining onto a white piece of paper. It could shine onto a white wall, something like that. You don't get just one image. Now you have 100 images of the partial eclipse. It's a lot of fun. Lots of people can see it at one time. It's not just one person individually. If you've got trees coming out, we won't have many leaves out here in our area by this time in April. But down there, I assume there'll be a lot more trees. Leaves will be out, and the overlapping leaves produce pinhole projectors. And here you can see the shadow and then the projection of the crescent sun on a wall just from the light going through the overlapping leaves in a deciduous tree. So another great way, if you have something like that in your community, in your playground, wherever it might be, Another one of my favorite, I shouldn't say favorite, and this really is something worth setting up, and that is how you project an image of the sun so it's bigger than what you see either through the colander or through the solar viewing glasses. Neither of those are big enough to see sunspots, and if you project an image, you get something like that. So this is the setup. You can see a pair of binoculars. You've covered up one of the lenses so that you only get sun coming through it. The cardboard also provides a shadow down here on the piece of paper so that you get a good place to put your image of the sun. This is what it looks like. So you can see, again, here's the cardboard, here's the shadow, and here's the image of the sun. A lot of people, this is something to try before the day of the eclipse because it takes a little bit of manipulating and so on. Because you can't look through the binoculars to aim it at the sun. Once you find the sun, it's too dangerous to look at it. So what you need to do is you got this piece of cardboard and you look at this shadow and you make sure that it's the same shape as this, because if it's not aligned, it'll be too elongated. And when you get it to be the exact same shape, you'll see then a nice little image will come up. Now, a lot of people will say, well, I don't have a tripod. Now, I have a pair of binoculars. I don't have a tripod. Well, if you don't have a tripod, here's the cheap version. This is a bag of Play-Doh. You can also use a bag of beans. Since you're not using this part of the binoculars, you just shove this into the bag of Play-Doh or the bag of beans, and you move it around. You have to do it on a table or a chair until this is aimed at the sun. Same process. And the reason for this is back to where I started way back when at the beginning, is that it allows you to actually see the sunspots that are on the sun. Back in 2017, well, actually, and to get a good sense of what it might be like, this is from July 17th of last year. And if anything, it's probably gotten more active, but this is a number of sunspots. Certainly in the center here, you can see one here down on the right, some over here on the left. Again, they change, they get bigger, they get smaller. As I mentioned earlier, they're like solar acne. But we can guarantee there'll be a fair number of sunspots. In 2017, we didn't worry about it very much because it was its solar minimum. The sun goes through a 11-year cycle from very few sunspots like this to a lot more sunspots. 2017 was minimum. And so we're now 8 years, 7 years, sorry, 7 years afterwards. So we're getting up there into a period when it's being very active. So we definitely want to go out and be able to see these sorts of things, to see the sunspots. If you want to, this is another, we have this one day of eclipses, but if you want to extend the experience, sunspots are something that are nice to follow. And you can have a group of students who are really interested to go out and regularly make observations. What happens to the sunspots over time? The sun rotates about once every 27 days. So you can actually follow the rotation rate of the sun, follow how the sunspot changes and so on. Again, there's easy ways to make pinhole projectors. This is something that a lot of people did when I was younger, just a piece of cardboard, piece of aluminum foil in the middle, put a pinhole in it, project an image onto a white piece of cardboard. Many people like to make the same thing, but in a cardboard box. So you have, here's the aluminum foil with a hole in it. Here's the paper to project the image on it. Now you hold this over your shoulder with the sun coming in over your shoulder here, and you're looking through the viewport with your eye, and you see an image of the sun here. Now it's a pinhole projector, there's no lens, so that means it's kind of a fuzzy image, but it's very, you saw what we saw in the colander. You'll get the same kind of image here, but it'll just be one image instead of many of them. Now, another interesting technique These are all, many more people can see them. It's fun to build a pinhole projector. There's a whole lot of things that make it more interesting than just, someone giving you a pair of glasses for you to look at. So you can make it a fun craft project in many ways. Another way to do this is instead of a pinhole projector, you have a pinhole reflector. And so here's a mirror. This is just a hand mirror from your bathroom. I'm hand holding it. I have to admit, you can't hand hold it. You have to put it on a tripod or into that bag of Play-Doh. But here's just a kind of a dime-sized hole, and you project an image onto a wall. So you get a fairly large image that a lot of people can see. The wall should be in shadow, so you have to make sure you can have the right setup where this is in the sun and the wall is in the shadow. More recently, I found an even more interesting way to do a pinhole reflector. So you see in the bottom right here a disco ball. This is just a little 4-inch disco ball. You could use a big one you'd find in a dance hall or something, but for $4, I was able to get this 4-inch disco ball. And each of these little mirrors that you see on there is a pinhole reflector. Acts just like that pinhole projector that we were doing. And each down here on the ground, you can see all these little images, and those are all, here it goes up on the wall. These are all images of the crescent, the crescent sun. There's a close-up of a couple of them. And if you take a really close-up, this is what it looks like. A little bit fuzzy because this is a pinhole projector. It's not a telescope. It doesn't have lenses in it, but it gives you a good sense. Certainly the same kind of image you get by looking through the solar viewing glasses. And you can see it's pretty distinct even on this brick wall. Now, if you had a white wall that was in shadow, you'd get a very nice image. So I highly recommend the disco ball. Lots of people get to view it. Of course, you have to find a location that's in the sun, projects out into a shadowed area. With that, I'm going to end the conversation about safe viewing glasses. If we have time at the end, I'm going to talk a little bit about our safe viewing techniques. If we have time at the end, I'll talk a little bit more about what people are doing related to early release and so on.
Dennis, we have a question from Christy, how to get the links that you mentioned earlier.
I'm not sure, did she say which link to?
She doesn't. She just said the links you mentioned earlier. So I'm guessing probably, obviously there's the NSTA links that are there, but I think you had a few more maybe.
Yeah, if she does denniста.org/eclipse, that will take her to all those resources. That'll be the easiest one. I can put that in the chat while we're sitting here. And that'll give her the resource. That'll give her that 28-page educator's guide. She can find out where to purchase Eclipse solar viewing glasses if she wants to. I'll say that's the one that you might want.
Okay. Marley said that she got a small disco ball, got a set of small disco balls on Amazon and a mini colander. I think so. Just sharing that those things are available there. Bethany is asking for the best viewing time in Tennessee.
So on the webinar, I gave a slide. Let me go back to that. Just a minute. It was way back, wasn't it? Further than I thought. There it is. So if she goes to this, she can put in her exact location. You put in a town, to give the time it starts, the time it ends, and the time of maximum coverage. Again, if you look at it, Tennessee's in the Eastern time zone, so it's going to be around the 3 o'clock period for maximum coverage. Again, it'll start about an hour, a little over an hour before that, and end a little bit an hour after that, but roughly around 3 o'clock. But she can get the exact time for her location there.
And Bethany, just ask if you have, I know you went over a little bit with safety concerns. I think that she might have come in a little after you talked about that, but could you just do a very brief reminder of some of the safety issues there?
Yeah, you know, it's certainly students should be told not to look directly at the sun without protection. Now, when I say that, again, during totality, you have to look directly at the sun, even use binoculars. The corona is very faint, but anytime you can see any part of the sun, you need to use either an indirect viewing technique, the colander, disco ball, pinhole projectors, or the solar viewing glasses. Students should be, you know, they shouldn't look directly at the sun without protection. But I want to emphasize how difficult it is, because that study was done in the UK that showed that there was no permanent eye damage by anybody in the UK during that eclipse. People don't like to look at the sun. It's very bright. So a momentary look at it. I keep on thinking that typically anybody who goes to the ocean and watches a sunset or watches a sunset anywhere, we tend to look at the sun. We want to see the sunsets. We're trying to see when the sun is setting and what the colors are. And you get spots in front of your eyes a little bit, but they all go away. It is pretty difficult to actually have permanent eye damage. Now, that being said, I wouldn't want to go out and tell students that. So they say, oh, well, let me try and stare at the sun for as long as I can. We don't want them to do that. But I do want to emphasize, both for everybody that's here, administrators and so on, that it's much safer viewing the eclipse than everybody thinks. That somehow, again, there's this idea that you look just momentarily and you permanently damage your eyes, or there's some extra radiation that happens during the eclipse, and there isn't any extra. So it's the right balance between, yes, you need to be safe, don't worry about it as much as people seem to. And as I pointed out, it's probably safer going out and observing than taking a trip on the bus to a field trip, and what might happen to you on a bus. I think
that's all the questions we have right now, Dennis.
Okay, well, let me come down to this question. Oops. On what we're hearing about. I'm gonna, well, here I will. This will be interesting to see for people to do, because I think we have enough time. We will go a little bit over 1 hour, but not too much. People should put into the chat what they know about their school, what their school's doing. School's canceled? Is it early release? Is it a regular school day? Followed by a statement of what they plan to do to prepare their students and families to make the most of the eclipse. It'll be interesting to see this. So if people could do that, I would very much appreciate it. I'll get my chat so I can see it. And while you're doing that, I'll talk a little bit about what I've been hearing, not exactly answering the question yet, but as I think I mentioned this to Stephen and others before we got started, I've spent a lot of time in Indiana and Ohio in the last month, and everything's over the map. School districts that I think, haven't even acknowledged that there's an eclipse coming. They haven't changed a thing. Others that a long time ago canceled school because it's during release time. Some school districts where it's release time for the elementary schools, but the high school students are already home. So what do you do there? And they have early release. Some school districts who have canceled have said teachers can use the school grounds for eclipse parties, and other places where they say, nope, you can't. Yeah, regular, I'm looking at what's here, regular school day. So they're doing something with their students. Oh, there's more people talking about, oh, well, Akron talking about be closed. Kent State University is going to be closed. No, in Arkansas, well, I don't know anybody from Arkansas, but we had the science supervisor from Arkansas on a webinar earlier this week, and the state has purchased for every student in the state Eclipse viewing glasses, which I thought was great information. So it really is all about, one of the teachers was going to have, she couldn't use the school grounds, and actually I will, if you look at what we're hearing from teachers, this is exactly what I'm showing. She's going to invite the families over to her house, and they're going to have a party at her house, even though they can't use the school grounds. Talked to another group that said, I don't think our administrators even know this is happening. We need to go back. This was in mid-February. This is, yes, mid-February. And, we need to go back and make sure our school district, is aware and figures out what to do. I think the most important thing is to actually be aware of it and come to a conclusion to let students go out. We've certainly had some school districts where permission is required for students to go outside. So there's a permission slip. It's almost like a field trip permission slip. Yes, my student can go outside, which means that students where parents don't want them to go outside need to have activities. So then it's thinking about, what am I going to do inside for those students that the parents haven't allowed them to go outside? So again, some of the activities, some of those art activities I talked about earlier are certainly valuable to do. Back to the issue of weather. Whether the students are inside or outside, the probability of clear weather is not wonderful. I mean, I think for most of the United States is about 50-50. So having live streaming set up, if it's wonderful outside, then the students inside need to see live streaming. If it's nice outside, well, they get to see what's happening there, but it will also be nice to see what's happening elsewhere. NASA has set up live streaming sites all across the path of totality, including Mexico. So somebody's going to get to see it. And if you're not in the path of totality, you want to see what's happening in the path of totality. So you want to have that set up for both people who are inside or outside. So that'll be a valuable thing to do. And so if, you might say, well, wait, I didn't talk about it. And I have to admit I didn't. But if you go to the NSTA website and go down to NASA at the bottom, click on it, it'll give you the NASA resources, which will get you to the NASA streaming video sites across the country. The Exploratorium is also working with NASA. Exploratorium is a science center in San Francisco. And so if you go to exploratorium.org, they also will have information about streaming opportunities. But one does need to be ready for cloudy weather, unfortunately. Okay, well, I think that is where I wish to end. I wish everybody clear skies for the eclipse in April. Hope you have a wonderful time.
Dennis, thank you so much. This was fantastic. I know that I'm going to use some of this in my email that'll be going out to people here in the next week to get them hopefully energized and ready for really and truly what is, kind of a once in a generation kind of deal. I got to experience the one in 2017 in Kentucky, and but the one before that, I was a freshman in high school, I think, back in the 80s. And so it's a very exciting time. I hope people take advantage of it. We have had a great group that's been online with us. Folks, we will be posting this video as quickly as possible. So we ask that you share it with your friends. Let other people know in your network know that this is available to them, as well as any links or other resources that Dennis has shared. Dennis, my friend, anytime I get a chance to spend time with you, even if it's just me sitting and listening to you talk, is a good day. And in my case, getting to do that and talk about science is a fantastic day. So thank you, my friend. Thank you for doing this and bringing your knowledge and resources to the South.
Well, thank you for having me. I appreciate it. This was great.
Awesome. Thank you so much. I hope all of
Okay.
you have a great day. And as Dennis said, clear skies for a great phenomena. Remember, it's all about phenomena.
Thanks. Bye, everybody.
Bye-bye.
Thank you, Dennis. I truly enjoyed that.
Okay, well, I'm glad you did.
And I'm